participants. Welcome all of you.
This meeting is being recorded.
Yes, welcome all of you to this deepfake detection meeting discussion panel. Right, I welcome and congratulate Dr. Varalakshmi M, who is an associate professor in Department of CSE from Cambridge Institute of Technology, Bangalore. Vaisali, Mrs. Vaisali, who is an assistant professor in D.Y. Patil Institute of Union and Technology, Pimpri, and Dr. Comfort, IMO State University, Dr. Sri Vignahema, Associate Professor in Information Technology Department, Bannari Amman Institute, Dr. Giovanna, University of Naples, Federico, and Dr. Krishnan, Professor Krishnan, General Manager, Organization Department, Narcos Limited, and myself, Dr. Aditya, Amrita School of Computing in Department of Computer Science, Amrita Visva Vidyapeetham, Amaravati Campus, Andhra Pradesh, India. I welcome once again to all of you for this panel discussion. Today, I would like to highlight the things which we will be discussing and focusing for the work, and I'll be sharing the screen. I'll be taking hardly 15 to 20 minutes, and then I'll open up the floor for this panel discussion.
Dr. Aditya, you need to unmute yourself.
Dr. Aditya, you need to unmute yourself.
Yeah, it's unmuted, sir. My screen is visible, sir?
It was visible.
It was visible.
Sorry?
Yeah, it is okay.
It is okay.
Yeah. This title which I initially fixed it, because we can change it later. This is about deepfake generation and detection, a journey of the past 3 decades. Now we will have a conversation whether we will make it 2 or 3 based upon the initial or starting paper of this deepfake detection, initial development on deepfake detection, that we can think, no issue. And coming to first, we will have abstract which will be written by myself and Professor Dr. K. Umachandran sir, and Dr. Comfort also can give her expert advice, right? And coming to introduction, okay, abstract we will write at the end after everything finishes. Coming to introduction, what I think is like introduction, we can start from deep learning, and before that we can discuss about neural network. Okay, so we can put neural network at the first, then deep learning, and try to establish a link or a relation between deep learning to deepfake, right? So this will be around 1 or 2 pages, not more than that. So this will come under introduction only, and coming next portion will be 1.1. So there we will be discussing about what is deepfake generation, okay, how it started, okay, how it generates. So it will be mostly initial idea only, so mostly 1 page. Okay, next 1.2 section will be about deepfake detection. Okay, what is deepfake detection? What are the research advancements in deepfake detection? These things, 4 to 5 paragraphs, maybe 1 page. Then we can discuss about origin of deepfakes. Okay, we can put 1.3, that is origin of deepfakes, at 1.1 also. Okay, that we will decide once we start writing the things. Origin of deepfakes, from where exactly this word started. Okay, we know Ian Godfellow started it, is that's fine. So those things we should mention, in which lab, why it started, okay, how it started, everything we need to mention. That will be mostly half to 1 page only it will come. Maximum 1 to 3 paragraph we can make it. Then some popular example, pictorial example, some kind of pictures or audio not possible. Okay, some kind of image kind of things we can put. Okay, so to show the illustration of deepfakes, that could be around 1 to 2 pages that we can keep. Everything shall be comes under introduction. And so next, application of deepfakes. Okay, so what are the areas deepfakes is applicable? Deepfake is applicable. So we can discuss those areas, and the same can be also shown in a diagram. Okay, like we can make a circle, and there are different branches. We can show these are the applications. Anyhow, we need to discuss what are the applications, how they are used, everything. Next, we can discuss about scope and contribution of our work. Okay, it can be around 4 to 6 bullet points, merely 1 to 2 pages. 1 page to be fine, I guess, right? So scope means what? Okay, where we start our work, like starting from the text generation. Okay, where we will end, like we will end like discussing about types of defects, classification, okay, and applications. Those things we will mention in the scope, and these are the contributions also. Some bullet points also we can make. Okay, this is about introduction. Sir, it is fine. Is it audible, sir?
Okay.
Okay.
Okay. Okay.
Thank you.
Okay.
Yeah, sir. So we will decide according to the convenience of the panel members, whatever we can take it. Now coming to this deepfake dataset related things. Now after discussing all this introductory part of about deepfake, we can go directly to the dataset available for deepfake. Some kind of audio dataset, okay, face-to-face dataset is there, okay, and image-to-face dataset is there. So we can discuss the origin of the dataset, who created the dataset, what are the how many samples are available in the dataset, what is the size of the dataset, okay, volume of the dataset. So all the things we can, all the possible number of datasets that are available, okay, at present, those things we can highlight. We can make a table also, there is no harm. We can also give the link of the source. Okay, so the objective for us is to clearly present everything about the data set in this second section, right? So this we can take 1 to 2 page also. If it is cross exits also, no worry. Okay, so third one is most important. This is the foundation of this work, I guess, foundation and the strength of this work, deepfake techniques. So basically, we can say about generation and detection, these two things, right? So whether it is generation or detection, how it happens. Okay, generation, we know we can use generative adversarial network GAN or auto encoders for generating deepfakes, right? So here in deepfake detection, we must discuss about the GAN and auto encoders both, right? And in that case, we must understand the what are the possible papers that are came till now, okay, in deepfake generation, right? And what are their merits, what are their issues, everything we must discuss with comparison on different parameters. We can make a table, okay, some 2 or 3 paragraphs and make a table, and then we can find 20 to 30 papers on deepfake generation using either GAN or auto encoders, okay, and we can discuss them. so this will take around 3 to 4 pages. That is always good only, because this is the core part of our work, generation and detection. Similarly, detection, how detection happens, who are the authors, proposed detection techniques, deepfake detection techniques, what dataset they have worked, what things they have detected. So everything we need to discuss. Same thing, we can take 20 to 30 recent papers, good high quality papers, okay, and making a table and discuss them with their merits, issues, benefits, problems, everything. Okay, algorithms, whatever they've chosen, we can make a table. I'll provide the sample also for how to do it. Then we can also discuss in this deepfake techniques classification. Like we have a visual deepfakes. Like, okay, this we can put before third also, or under third 3.1, 3.2, 3.3 also we can make. This is one is lip synchronization, face synthesis, identity swap, body swap, and puppetry, attribute manipulation. Different types of visual deepfake techniques are there. Okay, which are the authors' papers? Some authors' paper worked on lip synchronization, changing the lips, okay, or making the face changing. Okay, so such kind of papers we need to find out and discuss about them. Similarly, audio deepfake. So some of the authors have worked. Those things we need to identify and make a table. Everything, if you make a table, it will be very easy for later on understanding. Now, then finally, of course, we will discuss different kind of deepfake detection techniques with the gene-based detection techniques, autoencoders techniques, everything. Okay, and very important is evaluation metrics. That means the analysis. Analysis of performance measures. Basically, here we will be discussing about different types of evaluation metrics. We can place about like different types of loss functions. Okay, loss functions for gain is different. Loss function for autoencoders will be different. So we will be basically finding out what are the different types of loss functions for different types of defect detection techniques. Yeah, of course, we can also mention a table. Okay, some highlights about some works. What are the results about their loss functions? Okay, and everything we can mention. And finally, we will be highlighting the limitations. Okay, what are the limitations at present of various techniques, and what challenges authors are facing, researchers are facing with defect detection. Even one thing we can write, the challenges faced by the society due to defect detection also. And this is conclusion, future scope, and implications. So these are the various things which we can put in the section 6, which may be around 2 to 3 pages. That would be fine, right? So overall, there will be around say around 30 to 40 pages maximum. Okay, that is not a worry. We can anyhow streamline it. So now I suggest the panel members to decide which person who would like to take. And overall observation will be these 4 peoples. Okay, myself, Professor Krishnan, and Dr. Giovino and Varalasmi. Okay, they will be observing the overall development of the work. Okay, and other panels, based upon their choice, let them take whichever the portion they would like to work. So we'll share this Google Doc. Okay, and today onwards we can start working, and based upon our wish. Okay, like myself, Dr. Sahu. So my portion supports introduction. I can start Dr. Sahu introduction. I can start writing in the Google Doc. Right. So now it is your wish. Any portion you work, the leftover portion we will work. It's not a problem.
Very good.
So that's all from my end, sir. Please lead now, sir. Thank you.
Okay. Okay.
Thank you, all the members.
So I'll start with the introduction. And then I'll ask Dr. Vaishali to take over. Okay, Dr. Vaishali, have you heard me?
Yes, sir. Yes, sir.
Right. So let me share my screen and start. And after you finish, Dr. Vaishali, you have to call Dr. Comfort. And after Dr. Comfort, it is going to be Dr. Varalakshmi. And then finally, it is going to be Dr. Giovanna from Italy. Okay. So let me share my screen. Can you unshare your screen, Aditya, Dr. Aditya? Please unshare.
Yeah,
Stop,
sure,
sir.
sir. Stop, sir. Sure, sir. Yeah, please.
Right. Can you people see my screen?
Sir.
Yeah.
Yes, sir.
Okay. Going forward, thank you very much, Dr. Aditya, for guiding us properly with the outcome of this panel discussion, which is going to start from now. So our aim is, after we finish this panel discussion, we are going to enter into the process of writing and publishing in a indexed journal. That's where our aim is, because we don't just want to give a talk and forget it. We want to make it as a happening that can go further with the research. So our topic now is deepfake detection, and my portion I've started with this introduction. Okay, see, when it comes to deepfake is a novel technique, of course, with a negative effect, which is more paramount to detect media footage. This is where I've thought about. This technique is mostly from a AI-generated algorithm on a shared content, but of course, it is wickedly manipulated by the media. That is where deepfake, is taking more of its prominence. Manipulation of images and videos, which disseminate misinformation and may be real or fictional, but it impacts on the legitimacy and disturbs the public discourse, quality, and human rights. Of course, as it is a manipulation, it demands a greater challenge from all the stakeholders. This is where the gelling of people is towards deepfake detection and control. So this, this can be leading to an obscene, fraud, or prank, and it can even disrupt a legitimate function as it is being online, and it can also lead to a lot of negatives such as harassment and persuasion. So deepfake is not just a deepfake, but it has a major impact on people and their comfortability levels. Coming down after deepfake on a theory state, now the whole world is a digital vulnerable segment. We are unable to really distinguish what is real and fake. So to identify these things, we, having put our content in the digital space, it is highly susceptible for high quality spoofs. People can alter our face, auditory, our sounds, our speeches, and even textual matters. So the DNN, the deep neural network, which is being evolved, is taking consideration of the generative deep learning, that is the GAN. Okay, when it comes to GAN, the more important prominent players in this kind of manipulations are, one is the entertainment industry, and second are the prank stars on the social media. These people do it in a lighter way, but what happens is when it goes through a media, it affects the image of the person or the activity that is being carried out. So generative deep learning regenerates the media content, whether it is a injected media or a content or a replaced content. And at the same time, seeing from an entertainment or a prank perspective, these effects, whatever these injected or replaced media, is either promoting a wrong interest or improves upon a right interest. So these contents have to be looked into. This is where deepfake takes a prominence. So coming on to the aspect of coverage, which I wish to talk now is, our coverage will be onto mixing procedures, manipulations, intelligence architecture, deepfake learning, deepfake training, deepfake detection techniques, detection data sets, deepfake detection, then data sets in the market, detection methods, and finally, I'll close with generation methods. So some of the points are already listed by Dr. Aditya, so it can fit into wherever it is required when we are writing the paper. So the mixing procedures. See, mixing procedures are nothing but you take a live source of information, and when this information, it can be either a static information or a live activity which is going on and it is being transmitted. See, when we are transmitting, we also have the textual inputs along with the audio and video, which goes on with the video content. When it is being shared, there are a lot of interpretations that go on. People do a lot of advanced interpretations, but most probably the end users are video producers or filmmakers. They are the ones who interpret these things and make a practical usage out of the output. How do they do it is by delivering a high quality, which can be controlled by an analog system or a digital system which controls the codes and formats. This is the mixing procedure in a structure on which the deepfake is being manipulated. Again, coming on to manipulation, we should find out what is manipulation and how. See, manipulation is nothing but we do our impromptu changes in the data set. That's all. These data sets are of two types. One, the original data, and second is the manipulated data, which is more than thousands and thousands available than the original, because we really don't know which is the real one. So to detect which on the performance, generalization, testing, and detection, this whole gamut of deepfake takes a consideration. Now coming on to the things which are happening in the world. The two famous IT organizations, Google and Facebook, have already gone into deepfake. Google has already promoted a research on synthetic video detection, and it is doing a lot of activities. It has a lot of data sets available in the Google space. AI of Facebook has already conducted a competition which is called Kaggle, and they have arrived at data sets which are more than 100,000 video sequences from paid actors. They manipulated the videos, and they have identified and they've got a big stock of videos using deepfake, GAN, and non-learn methods. So these the things are also available for us to research and take it for our work. Basically, any deepfake is nothing but an intelligence architecture which is connected with a neural network. It has a learning, it has a training, and a computational power and capacity convergence. These things can be either for a right activity or a wrong activity or progressively changing activity. So any intelligence activity or architecture of this sort can be manipulated through deepfake, and deepfake is taking a more important prominence in that. Coming on to the learning neural networks. Learning can be either supervised or unsupervised, as we normally know. Supervised is nothing but we have paired and desired outputs, and you identify the error through a cost function, which is a mean squared error. It can be used for handwriting, speech, gestures, etc. And then when it comes to unsupervised, it's a model compared to a priori assumption, which is nothing but you compress on the mutual information, filter, statistical distribution, estimation, posterior probability, and clustering. All these things can happen. See, coming on after you learn, you have to train the system. The training system is on the three aspects, which is CNN, RNN, or GAN. So on these convolutional or recurrent or generative adversarial networks, deepfake training happens. See, again, like any AI networks, we have layers here. We have a propagation, either it's a forward or a backward propagation. Layers, we know it's input, hidden, and output, where the flow of information happens. Forward integration is propagation is nothing but you have a neuron and channelize it with the hidden layers, and you have to control the hidden layer through the output after you identify how much of an error happens. So this is where the forward propagation happens, and the backward propagation is you have input, desired output after the input itself. Then you model the output and weigh the output based on the errors which have to be corrected, model it with the desired output, and then you take a square error. Square error and weight are nothing but you increase the weight so that the square error drops to a minimum, or decrease the weight so that the square error drops to a minimum, and you identify your point of choice that you can go on with for the algorithm. These are common. Convolution is nothing but a lot of changes. It's not static. So changes happens, and this has to be identified through image recognition and processing. Of course, we are going to work on pixel data. So every pixel of the picture or video is going to be studied, and then the CNN will take its prominence. Of course, it goes with image detection and classification. From the you identify the object and take the image object detection, or you classify and take the instance. For both instances, you have a lot of channels. So you have different orientation, partial visibility of a picture or of a person or an animal or a thing or whatever it is, overlapping, different sizes, different classes, same class. All these things have to be channelized, and then you study it. For this, we have box predictions, which takes on with the objects on various axial formats like X and Y axis, and then you also classify your null objects, and then you go on ordering whether which is partial, which is visible, and which is null or overlapping. And then you do the bipartite loss matching. This is as we normally do for any CNN. Similarly, for a recurrent neural, see, it's a backward propagation. You have a fixed activation based on your past knowledge, which changes with time, because every past experience which is hidden has to be used for the progressive learning. So the current state, which is the one which is being affected by the previous inputs, are to be changed as a trained feature when it comes to the recent experience. So HT is a function of HT minus 1, which is the previous state, and with the input state of XT. So this is how recurrent neural functions. Coming on to generative adversarial, which is more prominent for GAN, for our deep neural. We have two neural networks here. One is the generator network and another is called a discriminator network. Generator network is the one, which should, it's a loss if it accepts a fake, a theme or a content. And similarly, a discriminator is a loss if it rejects a real one. So we need to find out both these networks work and adjust their weights and see to that the fake does not get into with the real population. So the binary classification is estimated here by probability. This is how GAN works on with our deep neural. Coming on to the detection techniques. See, normally in deep neural, it's more of a phase image because any production intervention which captures the phase image is on a 3D basis, on a 3D geometry, or onto a lighting, which affects it. So now, if you want to identify the detection part, you need to decompose the graphical image, the computer graphics, and disentangle it. Like, you identify the 3D shape separately, or take a common texture, or take a ambient light. In case of ambient common texture, you have to get onto the identity texture and identify the distortion, or go to the ambient light for a direct light and remove the distortion. By this, we can go for potential application of this technique for face recognition, liveliness detection, age estimation, etc. So this is a very prominent one affecting the future. Coming on to the dataset detections. Datasets are many, but the techniques which are available are temporal aware pipeline. There is one thing called bogus in middle, downsampling, spatiotemporal property, etc. Temporal aware pipeline is nothing but it goes on with a discrepancy which is intra-frame or in an interframe. In interframe, it is called as temporal abnormality, and they identify for the DeepFake dataset. When it comes to video streams, spatiotemporal property is used where the temporal incoherence is being identified for synthesizing errors, so that we identify the video stream which has the synthesizing errors, and then we can work on eliminating the dataset which is deepfake. Then coming on to the defense layers, like you have bogus in the middle, which is applied for the visual content, and downsampling, which is applied for the audio content. All these are on the settings of unimodel or cross model or an ensemble. So you have any kind of a setting, but this one is affecting the defense layer of the total sample assembly, which exists as a dataset. Coming on to the deep face detection. When we come to detection of facial expressions, the more important contributor is the 3D sensor, which helps us in identifying the full range of the face, for which you develop a tool and link it with a network. Network is here, we have a computer vision and a camera fusion. So these hardware and software combinations are going to be applied as interactive applications, and it has to be model trained. That's where I said model training is unsupervised training, and then you go on for production. So this deep face detection works on this kind of a network. We have a lot of data sets as of now. It's piling up in Google and in any browsers you take. We have Flickr faces, we have 100K generated images, we have 100K faces, DFFD, FS removal DB, and many things. I can read it out, but it's of no use as long as we think about using it. Okay, so there is a database, the real content and the fake content, which is already available, and I've also shared you the reference from which we have taken it up. Coming on to the detection methods. Detection methods are many. Deepfake, when we say it is a facial retouching, it can be improving a quality, stability, and variation. It could have been exposed deepfakes like face manipulations or machine human created face, fake face images, or face video forgery, or imagery using color cues, or GAN fingerprints, or speaker inconsistencies, or inconsistent head poses, tampered face, face wrapping, spoofing, spotting, artificial intelligence synthesized faces, or fake images using coherence matrix. All these are detection methods. Not limiting to this, we also have incremental learnings, detection using RNN, and then segmenting and detecting using a lot of facial images, world leaders being used as a trap, then convolutional strategies, retouching using synthetic alterations, photoshopped faces, GAN fake images, then optical flow, appearance and behaviors, then phenome visimi mismatches or metric learnings and blinking also. Like this, I missed capturing what Dr. Aditya said. He said about lip syncing also. So all these things are deep detection methods. Finally, coming on to my presentation is my generation methods. There are a lot of generation methods available in the market. It is multi-domain image-to-image translation or face capture and reenactment generation methods are available. Style-based GAN is available. Then adverse arbitrary image attribute editing, face swap is available. Then attribute editing by only changing what you want. There'll be many things in the picture, but you can choose which part to be, fake. Then image editing, manipulating images by sliding attributes. Many kind of these things are available. So with this, I stop my presentation so that, let this become an input to the paper, which we are trying to start. Thank you all for listening.
Thank you, sir.
Thank you.
Other panel members can kindly start.
Yes, sir. Thank you, Krishnan, sir.
Thank you.
Can I share my screen?
Yeah, please.
Yes. Good evening, all of you, all the panel members. Am I audible to all?
We can.
Yes. So already Krishnan sir told about all the methods or techniques, whatever we are using for the deepfake detection. Then I will focus on the research review on the deepfake detection. Most of we know that that is the many methods or techniques are used for the deepfake detection, but most probably we are using the GAN for the deepfake images. So nowadays means basically it is having the two neural networks and one discriminator, and in that it generate the text or some random noise as an input and attempts to produce a fake images as a generator, which are similar to real images data set. And we can say it is nothing but the discriminator takes both the real images and fake images as an input, and it estimates the probability of a sample coming from the real images data set rather than the from the fake images generator by the G. So it is a basic, or I can say it is the main technique to detect the deepfake images. Then next one is that is the end-to-end. We are using a classifier for the deepfake detection techniques. In that, we are having the many images, okay, and using the deep learning techniques, we are proposing image detection.
Dr. Vaishali, we are unable to hear you.
And this is applied for
Maybe
the 10 weights of face, and we
Vaishali, can you got interrupted? Can you join back?
Sorry, sir. It's maybe disconnected.
Yeah, please join.
Now I'm audible.
Yes.
Yes. So I think it's a miss. There are many techniques we are using for that. One of them, that is we are using the color components of the deepfake and real images and data set here already. Krishnan sir told that is the GAN used for the generating the deepfake images. That is the data we are using celeb HQ celeb A. It is greater than 98%, but again it is not evaluated on any practical case, means not on the live videos or live images. Okay, so next methodology, it is detection using convolution neural network, and for this that is the data set used celeb A, and GAN used for the generating that deepfake images, and evaluation data set, it is from the AI itself. But again, its accuracy is 80%, and but we can say its limitations or performance is not evaluated on deepfake images generated by the WGAN and the VGAN. Then third methodology is an assemble of neural network classifier, and for that again same data set used, and GAN is used for the generating the deepfake images. So accuracy is more, but performance is not evaluated on deepfake images and generated by the GAN and the this. These again we having the same, but again hybrid mode, two methods, that is the color image forensic and saturation method forensic. Then in this method again we are using the data set of celeb A, and most probably in all these methods we are generating the deepfake images using the GAN, and sometimes it is using the progress growing GAN. Again, this is nothing but the means initially we having the some fewer number of the layers. Progressive growing GAN means what? It is considering for the training the generator and discriminator networks, and as a result of generator, it can yields to the 4x4 resolution fake images. So it is something secondary method for this generating the deepfake images. And in that again we are using these crop images dataset Euro 0.56 and 0.54, but again we having the some limitation in that, it is giving the some poor performance in that. Then next method, it is design of the computer generated face identity CG face model. It is based on the customized CNN, and in that again we are using the same data set as above, but again here accuracy is higher, but limitations is it is not evaluated on the deepfake images. Again more than 10 papers I have gone through, and what are the contribution of that. Nowadays it is very important for the automated human face recognition as well as the temperature detection. In this paper, it is the it combines with the face recognition and the temperature detection using the deep neural networks system. For in this paper, what are the system design? It is achieved the accuracy 98.5% for the face recognition, and for the temperature detection 95%. Next, in the next paper, that is it represents the comparative study of the various deep learning based techniques for the detecting the deepfake videos. Means it is work on the deepfake videos. Okay, there are the 6 different techniques in that, but again we have to go on for the highest accuracy, and it gives a 99.5% result, but we have to use the two CNN methods differently, and it goes to the 98.5, means it gives a good results in that way. Then next, that is the overview of the methods, various methods for the creating the audio deepfakes as well as the neural text to speech and all. But there is not given any specific accuracy result for this paper. Then deepfake detection using the human face uh, images. In that, it is the user methods are face swapping, facial reenactments, and generative adversarial networks. All these techniques are used, and it can give the best method, which include the both traditional image as well as the processing based image. Next, this paper, it is focused on the audio deepfakes, and it can include the speech synthesis, voice conversion, and neural vocoders. Then in that, there are discuss about the only challenges, but not given any result about the what are the result they got, but only the discussion about the challenges of the audio defect detection. Next one is it is having the integrated part of the detection of the deepfake methodologies, and in that all the several steps are included. That is pre-processing, feature extraction using CNN and LSTM networks, and classification using an SVM classifier also. But again, in this they are not given any benchmark of the data set. It can give the only these data sets are used, that is the face forensic and celebrate data set, deepfake data set. But it is again obtain the higher accuracy than such as the GAN. Next one is the that is the deep learning for the deep fake detection. Then it can give the both the creation and detection of the deepfakes, including the generative models such as generative GAN and the variational auto encoders. Then it can give the various approaches of the visual artifacts, audio, and temporal inconsistency. Then in this next paper, again, it is a combination of the both audio and video deepfake images, as well as the only we can separate out the audio deepfakes. In that, especially textual features to detect the deepfake videos, and audio module extract from the using the MFCC and spectrograms from the. Then video model analyze the lip movements and lead movements of the speaker using the 3D facial landmarks. It is given. It is basically on the NLP, that is the natural language processing. In that, basically deepfake detection challenges are discussed, and it is given that the average accuracy, or we can say we are achieving the 0.99% accuracy using this data set. Then in the next paper, that is the performance metrics and standard data set and benchmarks and meta review. In that, they are creating the deepfakes such as GANs, autoencoders, and the neural style transformer. And all these we are having the develop the deepfake detection challenges. That it is only the review paper, and it can give the only standards and evaluating how we are evaluating the deepfake detection techniques. Then last one, I have gone through the paper, that is the audio deepfake perception in college going population. Then in that only it is giving the survey among the college students to understand their awareness and attitudes towards the audio deepfakes. Means it is only focused on the audio deepfakes. Though most of the students aware of the existence of the deepfakes, and but had limited knowledge about the audio deepfakes especially. So I have gone through all these papers. So any suggestion, then we will discuss on that. That's it from my side. Over to you, Dr. Comfort.
Yeah. Thank you, Dr. Comfort.
Thank you all.
Yeah, good morning.
Yeah,
Please
good
don't
morning.
share.
Yeah.
Please also virtually on share, please.
Go ahead, Doctor.
Okay. Good morning from Nigeria. Dr. Comfort Olebara. I'll be discussing deepfake detection techniques and effective models. Deepfake is a technology orchestrated by emotion detection. According to Eugene et al., emotion is the manifestation of a person's physiological and psychological state. Deepfake detection can be automatically carried out by a combination of sensors, rich data, and appropriate algorithms. Rich data now is, we've been talking about big data in machine learning. No matter how big the data is, the quality of the data is also of essence. Dr. Vashali has gone through some of the researches in this area, so I'm just gonna go through this. He has gone through this already, so I'll continue with my other sections. The steps involved in detection. Number one, you have to have an input or a target. Let's say it's a video you are trying to detect, if it's real or fake. It could be an image, it could be an audio. Then this serves as your input, maybe from the camera or from a storage location. Now this input has to be pre-processed. Pre-processing step for a video could be splitting the video into frames. And then if it's an image, now in this case, you now have to go through what we call face recognition. In the face recognition, you try to extract features of the face and then match it to a database containing data sets. Then the data set could be emotion data set that shows features that represent happiness, or when a person is happy, when a person is sad, when a person is moody, angry, and so on. So matching the extracted features in this database returns an output that kind of represents the image. Now, in the video pre-processing step, the first step will be to split the video into frames. I have in our section where you can learn how to do this, splitting any video into 2D frames and maybe the PNG images. Now, for instance, here we have a video as input. Now this video has been split into frames, and then from these frames, the face is cropped in the third step. Means that you're trying to capture just features of this person's face, and then capture it from various angles. And then this can form a data set, so that whenever this person's face is superimposed into maybe a porn video or anything, you can actually use the content of the data set generated from her video, viewed from various angles, to detect if that very video she's being maliciously presented in is real or fake. Now, the cropped frames can also be arranged in sequence to form a new video. And then this new video will be a new video of just the crop face. Remember, the input is a video of a total body, maybe with gesticulations and different positions. Now, this has been converted into frames that represent just her face and from various angles. And then these frames are further again processed into video, okay, that represent just her face. This same process, pre-processing step, can be carried out in audio. In the audio phase, we have audio frequency, which is the number of cycles per, or number of oscillations per second, or the audio signal, which is the general term that signifies audible range. The audible range should be between 20 Hz to 20 kilohertz. So this can also be split in frames, and then each frame can be analyzed or pre-processed to extract features, feature normalization, feature selection, and then train test, and all the processes involved in machine learning. Now, from the table one, which my colleague already discussed, we can pull out some basic methods of detection. We have the vignette detection, we have the subtraction detection, which is actually used in object detection, maybe in traffic and all that. And in the subtraction detection, this is trying to separate the focus, the target from its surrounding environment. Then we have the constraint detection, we have the image-based derivative detection, and then the parametric detection. Now we have basic tools. Firstly, every detection mechanism requires a data set. It could be real data set, or it could be generated data set. It could be celebrity data sets, because sometimes celebrities are trying to maliciously present them. Their images are used, for malicious attacks on them. Politician data set is also another very important data set. Then we have for or real data sets. So there are many data sets. Priority is that there has to be a data set when you're working on the technological science aspect of deepfake detection. Now, the second one is the input. What are you trying to detect? Is it a video, audio, or an image? The third one is the models. For now, I'm still speaking of technological detection of deepfake. So there has to be models. My colleague, Dr. Vashali, has discussed the models that has been used in researches, different papers, and all that. So the investigation now we have, there are basic parts of investigation when you're trying to detect deepfake. We have classification of image, whether it's real or fake. We have image attribution, which predicts the close set of generative models used to generate a fake image. It's no longer whether the image is real or fake. Now you have detected it to be fake. Okay, then which generative model was used? This is another phase, another level of detection. Apart from this, we have image parsing, which infers hyperparameters. In generative models, the important thing there is which hyperparameter was used. And then sometimes when these models are detected during training, some of the models are not found. So image parsing helps you to infer the hyperparameters used for the generative models that were not detected or not identified during training. Now we have the photo response non-uniformity. This has to do with analysis of noise patterns of light, like sensors from the light, the noise patterns that come up as a result of factory defects can also be analyzed, in trying to detect deepfake. Then we have the reverse engineering, which actually uses the output of deepfake to reverse engineer and get the source or the model that was used to generate it. The new direction in deepfake is just not the technological use of AI, but now we are looking at how can biological science involve in detection of deepfake. Remember, technology can do what it has to do, but it receives input from experts. Without the data set, then now who built this data set? Data set is actually a collection of information on a specific matter. Maybe you want to collect data set on a person, like we have the video of that person, like we showed earlier. Then we have the frame-by-frame videos. This can now be broken down into images and then fed into a system as data set. So without the input of human experts, technology would do little. David Toddington is an open source trainer. He's also an investigative intelligence service provider. He suggests critical thinking as the best approach, without just taking things at face value. If you see a video in these days of AI, you have to look back, take a step back and look at it again. It's not just, okay, let me get, how many people can use AI? But with critical thinking, a larger number of the community can actually detect, okay, this video is fake, this is not, this is real. So we are advocating for critical thinking as another means of deepfake detection. Technological processes use human-generated inputs and knowledge. At the end of technology, there are humans. No matter how the good intent of technology, such as GAN, ChatGPT, humans at the end who use this eventually turn it into malicious use. So AI learns from data and data generated by human beings. AI does not think critically. AI cannot go into the field to put on to gather information about a person. Actually, it waits until humans gather the information, feed it into the system, and then it learns from this system to give you or to predict an output. AI cannot change its mind about an ongoing investigation. Let's say it's investigating a criminal, and then halfway you find out that, oh, this person I suspect with all the things available, all the information available on him, actually what I thought, the way he's going and what I believe are not right so far. So, okay, let me change my direction, and AI cannot change its mind about an ongoing investigation. Now, critical thinking simply means being skeptical without being what? Cynical. Being skeptical, you don't believe things, you have bias in your mind, like you're presented with a video of somebody you know in a compromised position. First, why should I believe? And then you start looking deep. So we'll get to that. I want to just do a demo, but let me not waste your time. If I'm permitted to go straight to the demo, it will save us time. Can I go on, sir? Please let me go to my demo. Okay. In the demo section, I would want us to look at some of the things that has been used to detect whether an image is real or fake. For instance, we have this site that says this person does not exist.com. Okay, so you can train with this, you refresh the image, a new image is shown, you refresh it. This is GAN generative adversarial network generated images. None of these people are real, none of them, nobody here is real. So, and then we have the very important one where I believe everybody should be training with. And this one has to do with which image is real, which face is real. In this case now, you're trying to detect between two faces, which one is real. And what I look at, GAN does not generate perfectly things that are created with the hands. Anything that is like garments, eyeglasses, earrings are usually not perfect when they are created using GAN. So looking at this, once you generate it, first thing you look at, if the person wearing an eyeglass, you look at the eyeglass. If there is a clothing, you look at the clothing, and then with that, you take your decision to choose which one. Okay, in this case now, I can't see my, okay, let me review the screen. Okay. These are some of the games you can play. Then another image is here. Looking at this eyeglass here, just this section of the eyeglass, I looked at it. Then which image is real? I chose, because looking at the two sides of the eyeglass, this is actually not looking so real. So that's why we selected this to be the image that is not the real one. So we chose the one on the left. Again, we selected this as a result of the background. So these are telltale signs. For the background, the basic thing to look at is what we call bouquet. Okay, in this case now, what is this? This red issue here means nothing. So why should it be here in the one on the left-hand side? The picture on the left-hand side looks okay. The one on the right-hand side looks okay. But looking at the background now, there's just this, is it a pink or image here? It looks out of place. So as a result of that, we chose the picture on the right as the correct one. And then it returns to us that we are correct. Telltale signs. Number one, is there a human-generated object in the image? Look deeper, that particular picture might not be well arranged. Now, in this case, we are looking at the bouquet. Bouquet has to do with out of focus. That's the background now. The in focus is the object being captured. That's in this case, the human beings in the pictures are the being captured. But looking at the, oh, okay, the hairs are okay, the ears are perfect, the clothing are perfect. Then next thing, we are looking at the background. Looking at the background, you will notice that it's more like a picture, is way beyond a normal background. So we call that bouquet. Now, looking at the bouquet, it's obvious that it does not look natural. So we chose the one on the right as the original image. Now, very other important thing is that assuming somebody chats you up, and in the process of chatting you up, you don't know if this person is real, and over time, this person starts demanding money. There are many sites, open source sites, that will help you critically think and critically research on this person. We have the yandex.com, which is a Russian site that allows you to load up images and check if they are real. Okay, let me start with the one from Google. I loaded up this image from Google. You have images.google.com. And let's say this person has been chatting me up. I can actually research her face. And then if I choose to research her face, I'll not see her face did not come up. I'll choose to research her handbag and know if it will pop up somewhere in the deep web. Her similar handbags came up. Okay, now let me just look at her entire picture, handbag and face and clothes. And then I'm seeing similar clothes come up. Okay, this is images.google.com, but I've not seen this picture. I just want to see whether she exists somewhere. Maybe this person has been chatting me up. I want to know if this is a real profile or just a fake person using this profile. Okay, in this case now, this is yandex.com. You can now load up a video and an image and check if this image is real. Select file. I'm just gonna be fast with it, sorry. This is my image. I'm trying to check on this person. And blah, I have a video, I have images of this person all over the net. This is an image of her, and it does not only give me her image, it also gives me references to where this has been used. So if somebody, for instance, has been using this to chat me up, and then I can look at it, okay, this has been used in anti-scam forums, it has been used in Russia and different other places. Obviously, it is not a recent or a genuine or sincere image. PIMI does same. PIMI is face search. It has to do with facial recognition. Then the very important one I want us to see is the thin eye. The thin eye can be used to look up your company logos. It does not just bring out wherever it has appeared. It brings your if there's a similar image used somewhere, maybe in fraud. Let's say somebody is using your company logo for fraud. It will bring it up and show you details of the content of that data. So let me just use this and test quickly, run down and still test this image and see how it presents it. Okay, it found over 59.4 billion images in 0.5 seconds. For DeepFake, this particular image is what it searched for. And then it brought it up, showing me each details, the size of the picture, and so on. So assuming it's your company logo, it will bring it up, show you the size, and show you where it came up, where the name it was used on, and all that. So this is just ways of detecting deepfake. Permit me to go back a little and then tidy up my work. Okay, so having said all this, I want to show you how the important thing. What is the important thing? It is that every country, especially the IT community of every country, needs to be on up and doing. The data sets we are talking about are basically maybe Russian generated data sets, USA generated data sets, and maybe other countries generating their own data sets. And today we are using these data sets to carry out our own researches. So each country should have a data set of prominent people in that country, politicians, and so on. Like Nigeria just concluded her presidential election. Deepfake, I am sure, was used in most of the media presentations, media displays that we saw, with just different things being posted about the major players in the system. So assuming Nigeria IT community have data sets of politicians, whatever you say about them, we'll be able to investigate using our own internal data set. So each country should have, you as a person should build in your own data set of images, your own images viewed from different angles, just in case somebody comes up with something funny. What is the takeaway? Before you start hitting the search button, you have to ask yourself some questions. And what are these questions? What is my motive? Am I looking for somebody's profile? What are the questions I want to ask? Where should these questions be directed? Am I looking into the deep web, the dark web? I ask these questions. The how has to do with where is this person from? Let's say the person is from Russian descent. Let's say in the past when Putin was used, if you're searching for Putin, how is his name spelled? Is it an English name? Is it? So these are the questions, and this culminates into 3 basic sections of your activity. What questions should be asked? Where should the question be asked? How should the question be asked? Now, information, whatever information you receive through these searches must pass through what we call the CARS list. CARS list means credibility, accuracy, reasonableness, and support. Credibility, I've received this information. Why should I believe it? That has to do with what? Have that bias, have that second thought, think the thought. So why should I believe? Then you start digging to know if you should believe or not. Then how recent? Like in the image we've just looked at, looking at the date of that image showed 2014. So assuming somebody is using that image on me to send me chat now, and I look it up and it shows 2014, obviously you can't be putting on the same dress since 2014, even up to this 2023. That's practically impossible. So how recent is the image? It will help me detect if it's accurate or not. Reasonableness has to do is research based. What is the originator's view? I need to know whoever generated this. Is there any conflict between the 2 people? Is there any context, something at stake where because of this information or this position that is at stake, somebody can generate? So looking again, I need to know what is the reasonableness of this person in this class generating an image or video of this level. Another, the 4th one now is the support. Support has to do with, I have seen this video, I have seen this information, I've received it. Is there related information on this target? If there is no supporting information anywhere on the dev, like I tried searching my image using this method, it just showed nothing. That means if I'm doing it on somebody and nothing comes up, that means there's no supporting information concerning this. So with this, we now know we are equipped to go further. The resources are here, I listed them. Then also listed the FFmpeg is code for splitting of videos and audio. Okay. So that's my recommendation now is that every country, the IT community of every country should get into generation of data sets. Generating data sets of celebrities, of politicians, of prominent people, of the academia. In Nigeria, our Nobel laureate winner, Kubole Soyinka, just 2 days ago, announced a reward of $1,000 to anyone who could unravel a disinforming media calculation about him. So people can just wake up one morning, try to rubbish you, and then generate something. So imagine him at that level announcing $1,000 reward to whoever can unravel that disinformation. So this is how bad it can get. I want to say thank you for having me. Thank you.
Thank you, Dr. Comfort. Dr. Hema, can you take question?
Yes, sir.
Thank you.
Let me share my screen, sir. Good evening, everybody, to all the panel members present right here. So myself, Sri Vigna Hema. Let me proceed with my presentation. And my part of work in this research is different neural networks for emotions and faces. So as the previous panel members and my colleagues are deeply introduced about what the deep learning and what are the algorithms and what are the neural networks we are going to handle, and the GAN about the deep fake detections and generations. So all the demos have been beautifully explained by Dr. Comfort. So coming to my topic, the different neural networks for emotions and faces. So we all know about what is a neural network and how the neural network been important in machine learning algorithm and how it is being structured and functions, right? So likewise, so we have different thoughts of having this neural network that could be a composed of the interconnected nodes or the neurons. And then we have the training, and during that training process, this neural network is being presented with a set of labeled data, so which can then use for the learning processes of the relationship between the inputs and outputs, which detailedly explained by Dr. Comfort. And we all see that demo also by having that inputs and outputs for the GAN and the network that adjusts the strength, the connection between the neurons in a process, which is also being shown as a back propagation mechanism. So this is how being the minimizing the difference between its predicted output and the actual output. And coming to the neural network, it also has a wide range of applications. Even it is being the application of image recognition, speech recognition, NLPs, that is natural language processing, and some other recommendation systems too. And it is being well suited for the emotions and face recognitions also. So for that, we are going for different neural network for specifically for the emotions and faces. This can be used for analyzing the emotions and faces by including these type of neural network as of my research. And the first one is this CNN, and secondly, it has the RNN, then GAN, and motion recognition network. First of all, the CNN. So we all are familiar about the CNN, right? So the CNN are commonly used for the image recognition purposes and for the classification task, as I mentioned here, as in facial recognition. So they all work by applying a series of filters to an input image. So we will pre-process the image while we go for this type of algorithms. Okay. So while we pre-processing and we will extract the features, right? So then it will form the applying the series of filters to an input images. It will predict the output as an extract features. Okay, which are then used to make a prediction about the image, whether it has been a deep fake or and it is totally based on the emotions and the faces. Then comes the secondly, we go for this recurrent neural network. So these RNNs are designed to analyze the sequence of data, such as it might be a audio or the text, or often used for the NLP task. Okay? So they can also use for analyzing the facial expressions by treating the sequence of frames in a video as a time series. As we have the video slots, we have the frames. Each and every frame has a different images and the facial expressions or whatever the features that have in the video as represent as the images and it's been as a frames, right? So based on that, we have that sequence of frames and it is being treated. Okay, then after treating those things, and we are analyzing the expressions of faces or expression of the emotions by using this RNN. And coming to GAN, so it has been explained by the panel members, Dr. Vishali and Dr. Comfort. So they have mentioned a detailed explanation about that. So I'm not going to touch this topic in detail. Okay. So instead of that, I'm going for the emotion recognition network. So these are also the neural networks. It is especially designed for the emotion recognition tasks, such as classifying the facial expression or analyzing the speech. So these all are come under the emotion recognition network. And this network often use the techniques such as the facial landmark detection and feature extraction to identify the patterns associated with different emotions. So whatever the emotions, it may be a sad or happy or whatever the emotion is, we are finding that patterns and we are extracting the features based on the different emotions. Okay, so by having these different neural network for emotions and faces, Okay, the choice of the neural network architecture will be depend on the specific task at hand, and it has been the type of data being analyzed. So this is how we are taking a choice of this neural network. Then comes the first method I'm going to discuss with you all is heartbeat model. So as of my research, I'm currently in the deep learning research, where I have felt this heartbeat model is in the field of the deep learning on fakes. So this heartbeat algorithm is implemented to learn the appropriate facial expression by first estimating the facial expression from the existing image. Okay, it is then able to reproduce the expression itself. However, it is limited to 1 by 1000 seconds of heartbeats in the data set. So I have referred some research articles relevant to this of the current years, and I will show some of the uh, papers which I have chosen for this heartbeat model. Yeah. Okay. Yeah. So first of all, you can see here there's a heartbeat detection, okay, where the experience of emotions being taken, and they have chosen the heartbeat detection based on empirical investigations of the relations between the visceral self-perceptions and emotions, where they have the 52 undergraduates, they have 19 males as well as the 33 females. They perform a heartbeat detection. Okay, so where they classified as good or poor heartbeat detectors. So here, out of these 52 undergraduates, whereas this 90 males and 33 females, the good as mentioned as n is equal to 9 and poor as n is equal to 43. Okay, out of 52. So they have mentioned good and poor. Okay, so they have classified here as a heartbeat detectors, and they are presenting with a set of 2 film clips. So each targeting one of 3 different emotional valences. It may be amusement, anger, and fear. So if it is a wondering something and the expression is being an amusement, they are going with this amusement emotional balances and going to the anger. So we have that anger phase, okay, that expressions of anger. So that represents here as an one of the emotional balances. And coming to the fear, that expressions of fear. So we have some examples and samples right here. So once we go through these, how it's been the detected, it's based totally based on how the heartbeat and heartbeat detection and the emotions of the expressions, right? So I have mentioned these in my paper, and here they have compared the film type with the intensity, where they have mentioned that intensity rating to be 3 pairs of limbs for good and the bad, sorry, good and the poor heartbeat detectors, as shown in this figure. Okay, so that indicates the good detectors that reported experiencing greater intensity of emotion than the poor detectors, they across all 3 film types. Okay, so here you can clearly visualize that good and poor. Okay, so with this intensity level for amusement, anger, and fear, so they have taken those data set and they are processing the steps as we mentioned in the previous speaker set. Okay, likewise they have segregated for this amusement, anger, and fear. So this is of the film type, and this mean intensity ratings for this will be comparing to the targeting expressions. Then comes the pleasantness rating. In the pleasantness rating, here we go for the detection. Okay, so in order to check that the film elicited the intended emotional balance, it might be amusement, anger, or the fear. They evaluate for the subjects, and they have the elicited of small negative evaluations, and the pleasantness it will rate upon the heartbeat detection. So whether it is a good or the bad, and based on that, it will detect and it will show us an between subject variable and the film type main effect of the film type. Okay, as I showing here. Okay, then comes the measurements, and some of the measurements has been done in this based on the heart rate as well as the skin contents. Okay, so these are the things that comes in the one of the research article I have gone through. Then comes the Bayesian type. So the Bayesian deep learning framework. Okay, so this is also being one of the part of this heartbeat detection. Okay, so which it's totally predicting the end-to-end prediction of the emotion alone. So in this work, they have chosen, okay, they have chosen the problematic procedure for choosing to accept or reject the model, and the output is according to the intended application. So this actually take the data set. So two established data sets have been taken and it has been benchmarked, and it achieved the peak classification accuracy of 90% by using this Bayesian neural network. So it is also one of the technique we can use for this emotion and emotion recognition by end-to-end learning, right? So then they have the real world domains such as a healthcare. We can also applicable for the healthcare platform where the high premium is placed on a non-invisible collections of data and predictable certainty. So we can also go with this results part. So where they have the n number of classifications and do the calculations for this scores. Okay, so they mainly focus on the data sets, and they have given amigos and dreamers, and they have compared those with LSTM, that is a non-Bayesian one, and the CNN you all know about, that is also a non-Bayesian, and then comes with the LSTM and CNN, that is also an non-Bayesian, and LSTM with the CNN with an approximate of value of 0.5, where they have some accuracy level, improvement of the accuracy level for both the amigos and the two different data sets, as I said before, amigos and the dreamer, right? Then comes the, we are calculating that the alpha part with 0.9, even that accuracy level is being enhanced while comparing with the other LSTM, CNN, and while comparing the LSTM and CNN. So this totally depends on the CNN as well as the LSTM, the conventional LSTM. So I have gone through all those things of the results, and plus they have the greater accuracy level in the part of the this Bayesian with the combination of LSTM and the conventional neural network, that is a CNN. So again, I'm coming up with my presentation. So where the next part of the model is emotion olfaction model. So this EOM, so this is being a theoretical framework that proposes a link between the emotional experience, okay, and emotional experience and the perception of the odors. So depending on the odors, according to this EOM, the odors can evoke emotional responses, right? So where they can easily react for that odors. If it is a pleasant odors, they can easily have that facial expression with wondering, that is amusement, or having the happy emotional expression, right? So according to the EOM, the odors can evoke the emotional responses by activating the limbic system in the brain, which is involved in the emotional processing and memory. The EOM suggests that different types of odors can be associated with different emotional states. For example, I said earlier, the pleasant odors such as a lavender or a vanilla. So this is for an example. So these are often associated with positive emotions, right? So we can segregate these as positive emotions as well as the negative emotions. So while we go for this lavender or vanilla, so it's been a positive emotions. So it shows the happiness and it shows the relaxations, right? So while we go for the unpleasant odors such as a rotten egg or some garbage smell, okay, so that odors are associated with the negative emotion, such as it is a disgust or anger. Okay, we can separate these as an positive emotions as well as the negative emotions. So the EVOM, that is an emotion altercation model, which has been used in various applications, such as in marketing and the product design. These are the places where this EOM is applicable. Okay, so this is where we can choose where the marketing and the product design. So to evoke the particular emotional responses in consumers through the use of the sense. It also has been used in neuroscience research also to investigate the neural mechanisms that underlying the relationship between the altercation and the emotions. So we can correlate these things, right? Altercation and emotion. So however, it is important to note that this EOM model is still a theoretical framework, and there is ongoing research to better understand the relationship between the orders and the emotions. So I have gone through some research work also, and let me show some of the works. So mood, anxiety, and olfactory dysfunction in COVID-19. So this is evidence of the central nervous system involvement. So here they have exclusively used that PHQ and GAD, and they increased from the baseline to the enrollment, and they have diagrams of the symptoms and such as the SOB that will associate with the severe manifestations of the COVID-19. So only the severities of the smell and the taste loss, they're associated with the depressed mood and anxiety. So these are the things they have analyzed, okay, analyzed, and they have the study to determine the burden of the depressed mood and anxiety during the pandemic times, and it associated with the disease characteristics too. And we have the trans olfactory tract here, that the penetration of the central nervous system by this pandemic virus called as coronavirus, as you all know. So where we have used this olfactory tract right here. Okay, so this is one of the applicable area we can go for it, and so this is one of the things where the spatial frequency temporal convolutional recurrent network for olfactory enhanced EEG emotion recognition. So they have gone for the use of the EEG features from different domains, and they have combined the CNN and bidirectional long short term memory, that is, you know about the MILSTM, for EEG emotion recognition. So they transfer the EEG signal into the 4D representation that retain the spatial frequency and temporal information. We gone for 4D, okay? Then the representative or fed into the 3D CNN as well as that the bi-LSTM model to recognize the emotions. So the way they fed up with these models, they can easily recognize the emotions. And finally, the CNN is applied to learn the spatial and frequency information from the 4D representations. So they have used a 4D representation, and they designed to extract and forward and backward temporal dependencies. So as of the result, they have conducted 5-fold cross-validation experiments 5 times on the OVPD data set. They have chosen the OVPD data set. We can go through on this article in order to evaluate the performance of the model. And finally, the result produces as an average accuracy of 98.29% with SD of 0.72% under the olfactory enhanced video stimuli, and an average accuracy of 98.03% with SD of 0.73% under the traditional video stimuli on the data set used in this article. And they have also using the 3-class classification, that is a positive, neutral, and negative emotions based on the data set. And to verify the generalizability of this model, so they have approached the public EEG emotion data set, that is a C. Okay, so we can have this as a reference for our model, which can be applicable for this EEG emotion recognition. Okay, I have gone through with these papers, And coming back to the slide, and last is head radar neural network. So now we have been concentrating on the deep learning. So it is really good for the object detection. This head radar neural network is good for object detection, and however, it is not good at facial detection. Okay, the head radar, it uses a machine visions to detect the expressions in the brain of an actor whose brain shows that he is smiling will be matched to the other smile related expressions in the data set, which is involved in the database. Okay. Then in order to train the network algorithm on videos of real actors and their movements of the mouth, it brings as an observation method, but will not work for the creepy or the obscene expressions. We can go for these movement of the mouth, and we can train the network algorithm, but we can't go for these obscene expressions. So these are the work I have undergone for this head radar network. Once again. All right. Yeah. So here we go with the spatial expression recognition in videos where they have the tried things. So this is for CNN convention LSTM, as we discussed before. Okay. Then comes to the emotion recognition using different sensor and emotion models, methods, and data sets. So here is an review article where we have both with this applications that in the examples and developments in emotion recognition, so that we can clearly clarify with what are the recognition, emotion recognition, and its applicable areas for this different neural networks. I have also gone through with other references, like not only for emotions and the faces. These emotions and faces also has been detected with some other works, which I have gone through with. Apart from the heartbeat model and the head radar model and olfactory model, so even the CNN, RNN, and other emotional networks also taking a crucial role in this emotional recognition and facial recognition. So this is one of the work with the CNN, where it has the plunge into how the system can correctly detect, recognize, and classify the human facial expression through various image sensor by using the CNN. So the data set they have used is facial images, and all the images are used for training and testing purposes, and they are implementing the CNN in the MATLAB software. Out of that, the 80% of the image data set are used in the training the system, while the other 20% are for testing purposes. And the trained CNN classifier that classify the image emotions and the by using this Adam optimizer. Okay, that is for mainly for higher the accuracy. So while we gone through with this, we can have this Adam optimizer for checking the accuracy level, okay, while using the CNN. So likewise, I have gone through this, the other algorithms, neural network algorithms also. Hope this will be finding for the different neural networks for emotions and faces. I'm also gone through with, I'm also having the plan to go through with the different algorithms or the neural networks, which can be helpful for our further enhancement in our work. Hope this suits our algorithm. Krishnan sir, I'm signing off with this.
Thank you, Dr. Hema.
Yes, sir. Thank you. I'm
yeah, please, Anshay.
Thank you all for your patience with me.
Dr. Varalakshmi, can you please?
Yes, sir. Yes. Yeah. Just a second, I'll share the screen.
please.
Hope I'm audible.
Yeah, you're here.
Yes. Yes. So is it visible, sir? The slide.
Yeah, it is visible, ma'am.
Yes, sir. Thank you. So good afternoon, one and all. Thank you, Krishnan sir, for the wonderful opportunity. And thanks to all other panel members who have shared your insights. That was amazing. So today I take this opportunity to share my work on, a sort of deep face recognition, which was carried out, in fact, during the COVID time. When we were literally in the lockdown, we just came up with an idea wherein we can automate the human face recognition as well as the sort of login credential, because wherever we go, either we make use of the fingerprint recognition or some sort of manual approach. So during the 2 years, we just thought of developing a model or literally a system which is going to literally, recognize a people's face automatically, as well as the login credentials are going to get stored, and the temperature also would be sensed. So all the three was taken care, and the model, or rather the system developed, was called as FRTDS system, which basically stands for face recognition and temperature detection system. And we had made use of deep neural network concept for this whole model. So yes, so this is an overview of the contents covered in the presentation, and the abstract, which details like basically why we went for this thought process. As I had mentioned just now, I don't think like it was a need of the hour only during COVID, but it's a prolonged thing. Like over the years also we feel an automated system, almost like when you move inside a particular place, it senses your temperature as well as the face recognition is being taken care automatically, and parallelly your login credentials is also getting updated. So it's like almost you keep moving and things are taken care. So that was the main reason. And second important thing is the model was developed in such a way the person has to just stand for very few milliseconds. Almost it was in picoseconds in front of the system, and the distance also was like reasonable distance, around 70 to 90 centimeter away from the camera, in order for the whole recognition and the temperature sensing to take place. And there is no restriction with respect to any facial, the extra things worn. For example, the face was recognized even when the person was wearing a mask, or well, today they come with a beard and the next day they don't have the beard, wasn't a problem. The changes, because usually these are the drawbacks that are faced when it comes to face recognition. With a mustache or without a mustache, hairstyle changes for the other gender. So all this was taken care, and I'll be just explaining in the other slides. So yes, so this is what I was mentioning till now. So the major two components of the whole model was face recognition as well temperature detection. So I want to concentrate more on the methodology, the approach I had used in order to develop the model. To start with, when we consider these two parts of the whole system, that is face recognition and temperature detection. Temperature detection, I can tell it was like quite easy for us because we made use of IR proximity sensor. And in fact, we also had the thought process of going ahead with thermal sensor, wherein based on the the images extracted from the videos, the thermal sensors is going to measure the temperature of a person. But there were few drawbacks in that. I think for this session, I need not touch upon that. I want to concentrate more on the face recognition part. And that was the reason we just dropped off that, and based on our work and accuracy measures, we just moved back to IR temperature sensor. That was more than sufficient, and it was giving us 100% accuracy, truly speaking, and it was working completely fine for us together also. We had run the model or the system continuously for days. So it was really giving a very good result. So coming back to the face recognition. So when it comes to the face recognition, seriously, we had several challenges. And people might have a question now, how face recognition is going to be related to the deep fake detection. For deep fake detection, I believe the basis or the initial step would always be a face recognition. If this goes really fine, literally extracting the features of a real face is very, very challenging. Once you are able to get it done perfectly, then obviously getting along with the techniques for deep fake detection will give us more accuracy. So when we try to go ahead with face recognition, and this was actually carried out for our own employees in an organization, we aim to come up with a model which will be able to recognize minimum of 500 faces. But unfortunately, actually, we were able to do it with maximum accuracy in the sense 99.29 was almost for very minimal faces. Almost when we started moving towards 30 phases itself, the accuracy dropped down to 85 to 86%. The reason being, the database or the data set which was getting created automatically, means dynamically on a daily basis. So that is how we have developed the model. So dynamically it starts, detecting the faces, and the data sets gets updated appropriately. So what happened, it was like we were in need of a supercomputer in order to store the data set, or finally we had to load the full thing to the cloud. So that we have just kept it as a next phase. We are literally working on it now. But as far as those 30 phases or 30 employees are taken into consideration, the accuracy was way high. And so when it comes to the face recognition again, the major challenges what we faced was the first and foremost thing, as I told just now, the different changes that happens almost on daily basis. And the second important thing is the orientation of the face. We can't sit and hard and fast rule to the people telling like you have to stand literally straight in front of the camera, focus only on the camera, right? For few seconds or minutes. Yes, it does work out, but not every time. So the orientation does vary a lot, right? And the third important things comes with respect to extracting the important features out of all the features. So what was more important is trying to create a strong data set at the back end for every particular person. If suppose I take ABC as a particular person's name, then for that single person, so many orientations and so many different types, or different particular positions of the faces were created automatically. From one single face, we'll be capturing only one face at a time. But for that same phase, we were developing a model, and through our techniques, we were creating phases, the same phase in multiple orientations. How would it look like? And not only that, we were able to literally alter the orientations also. For example, if the person is slightly turned on one side, we were able to do in such a way automatically it is brought back to a specific orientation so that the recognition goes really well. So now, in order to carry out this task, there are several steps that has to be followed, which is the basics for any particular image processing task. And even if you have to develop a model and train a model, a machine learning model, these basic things has to be taken care. So the first and foremost thing was with respect to pre-processing. So the need for pre-processing was actually to take care of the brightness of the image. For example, the first problem was with respect to the illumination. So whenever we ask people to share their pic, when you're developing a model, usually we have to train it, and then only we can allow it to test. We can ask a model to test for new instances. So when we ask people to share the pics for the training purposes or to create the initial data set, it so happened the illumination, the lighting effects were entirely different, and people literally share the pics in different environments. So that was an eye-opener for us. Of course, we were aware that illumination does play a key role, but we never thought that would be the major concern for us. So literally, we worked on the pre-processing phase wherein we have to completely get rid of this illumination problem. We have to take care the brightness part and the dull, less brightness, so many things were there. So what was more important over here is, first and foremost, in that whole image, when the model or the system is capturing that particular image, or in a video stream, you take one frame after the other, you have to literally subtract the background and concentrate only on the human face. Even when the human image is obtained, that's more important, wherein we try to cut the face literally from that image. So finally, we have to come or resize, come to the position of the face alone. And next important thing was like, in order to handle that brightness problem, what we thought was better to go with a grayscale image, because we don't have this color problem. So that was easy for us comparatively, which was which was helping us literally to not to be dependent on the complexion, of the face. So that was more easy for us. So literally we converted into grayscale. Thereafter, we concentrated more on histogram equalization in order to come up with normalized value of the pixels, and thereafter contrast enhancement was also taken care. So all this put together was in the pre-processing phase, and hard cascade approach was used in order to detect the face in the whole image. So after the image was pre-processed, like we have got the actual image, then we concentrated more on typically detecting the face over there. And from the detected faces, what was more important was, as I mentioned just now, we had to perform some transformations. So as I told, the various orientations of the faces needs to get created, and tilting. For example, if the person is slightly bent down or too high, all this has to be corrected. It's almost similar to how we do certain operations in the images or the pics in our gallery using the smartphone. The same thing. We try to rotate, we try to tilt, right? In whichever orientation we want, we can try to fix it into. So for one particular person itself, we were able to generate multiple orientations of the images at the backend, which helped us to gain maximum accuracy. An extremely important thing is, once we are able to get the aligned faces in the appropriate way how we need, then we had gone for feature extraction. So first one was concentrating on feature generation, wherein whatever features are present on the face, like earlier when we used to implement the so-called face detection or recognition algorithm on our own, I do remember there are certain features which plays a major role on the faces. For example, the distance between the eyes, the length of the nose over there, and the contour, okay, the overall contour, the forehead measurements, like that. There are several features, but nowadays the deep neural network, it goes for identifying lot many features. So amidst all those features, the next important thing was trying to extract the most important ones. We had to concentrate and pick out the crucial or very critical features, which are also called as, like, it will be stored under feature embeddings in the deep neural network. So those phase embeddings which were created, finally it aided us a lot in order to perform the classification. So if suppose we had, as I was mentioning, suppose we had around 30 employees whose face was getting recognized, then for all the 30 employees, as I told, the recognition was damn perfect because the face embeddings was created in a very perfect manner at the backend. So this aided us to perform the face recognition and live stream also. So though we developed a system or a model like a box-like structure wherein the person has to stand in front of it, but later we found out as a person was moving inside the place, we just tried to fix a camera over there and then perform the same thing. We linked it to our model. It really worked out well. So there was no need even for the people to stand in front of the model to get the work done. So this was the overall design plan. And to get a bit more into the exact tool that was developed. So this is basically the captioning and augmentation tool, which means when we are trying, as I was mentioning till now, so the moment we are trying to collect a person's face, what was more important is how well we are trying multiple orientations of the same page. This was done automatically through the model. So the model what we created, using Keras, we had made use of, we have developed a model. So that in order to develop the tool. And once a face detection was done, what was more important was resizing the frame. As I was mentioning, the same step, the full image has to be resized and the grayscale filtering has to be applied, histogram equalization, and based on the need, random rotations has to be carried out. And finally, we were able to create a face like how to tell, several directories for or several folders for each particular person. So for one person, one particular folder, which will be having lot many facial images of the same person. So it's like fulfilling the images in any particular direction. It was easy to handle it. Yes. So next what we did was for each person, whatever phases we have created, using that we had trained the model. So in order to train the model, again, the next important thing was the deep neural network. We had made use of the deep neural network wherein we had the convolution layer, the max pooling layer, and then the output layer. So convolution layer was mainly concentrating upon, collecting all the features. So when we try to analyze a convolution layer in depth, we got to know the various features that was extracted from that image. Thereafter, this max pooling was mainly done in order to concentrate on the, as I was mentioning just now in the previous slide, the facial feature embedding. So these embeddings are more important. Usually what happens is the deep neural network, it will be representing these embeddings in a hypersphere representation. So many people have tried to deep dive into this topic to understand what is that so many numbers, the unit hypersphere representation. But basically the deep neural network does this. It will be creating the representation in that particular fashion, and the right hand side image, the pic what you see over here is nothing but just the just one phase of the representation, how it shows. You cannot try to identify the 180 128 feature embeddings over here. If typically if you start numbering even the dots, usually the count doesn't match, but this is how the DNN will be projected. If you try to analyze and see it in depth, it will be just giving us an overview of the hypersphere representation of those images. Thereafter, once this was done, since it was almost like one-to-one mapping of the faces. See, for one particular person's face only, we are creating so many orientations of the faces, and a typical data set is being created. Almost like one-on-one mapping we were able to do using this. So a simple SVM classifier was more than sufficient for us in order to classify and typically get the name of the person. So basically the classifier was actually used in order to map those facial features to the name. Again, that was a sort of mapping table which was maintained at the back end. And in fact, we did not make use of the concept of the name, obvious. Once people have shared their pics, we try to generate a unique code or a unique number. So automatically we were mapping the features to that unique code. So that problem was handled. And once that unique code is retrieved, all the details of the person, we were able to get it. So this is how the complete flow it went. And yes. So when it comes to the discrepancy elimination algorithm, what was more important over here was once we made use of the SVM classifier, when we try to train the model, we tried to develop more iterations, but equally we were, it was more important for us to see to that the system doesn't enter into overfitting condition. This was another problem what we faced. For example, the pattern what we see here, it was easy to generate the pattern in this way so that it can easily map it to the person ID. But it so happened, since we were doing it from the same person, we were collecting lot many images, right? Or just 2 or 3 images. And for the same person, we were able to generate lot many images. It so happened, once a model got developed and we started training, it was almost like one-on-one training. So typically it was an overfitting condition, which we found out at the later point of time. Then we tried to avoid it, and then we pulled in a manner wherein it shouldn't be either underfitting or overfitting. So in that way, the model was analyzed and the parameters were set, and finally it was trained and ready. So temperature reduction, as I told, it was by making use of infrared proximity sensor. And next thing is, this was the initial model what I told, wherein they have to just keep, that particular phase, through the phase and through the distance itself, the IR sensor checks it, the temperature. And thereafter we had a GUI wherein the values were displayed, the temperature and the details of the person was displayed. The GUI also was developed and it was connected to the backend. So I wish to brief upon the results that we have obtained after implementation. So first and foremost, we were able to develop a system which is like almost all-in-one system, and a simple web-based application was developed as a front end. And next important thing is operational time was very minimal. The latency was almost nil over here. And we had tested on 20 different classes, right? Testing was, initial training was for 30 different employees, and testing also was carried out for totally different. This is where like almost we were happy about the performance of the system. So dynamically it read the faces and it carried out the task, and it was able to recognize even new instances. So that was we were happy about it. And next thing is 30 images per class was created. And the deep neural network, we talk about the number of times the training has to be carried out. The threshold, identifying the threshold is usually a challenge. Once the threshold is fixed, as I told, this overfitting and underfitting condition can be handled easily. So the training epochs was actually 100, and the prediction accuracy was 84 for maximum images. For 30, it was the perfect accuracy, maximum accuracy. But as it increased, the testing for 20 instances, then to 30, then to 50, then to 80. So the accuracy at one point of time, it halted in 84%. So the results I've shown, so this is just a small system which was completely developed by a student, and small sensors all in the level of the internal architecture, internal connectivity. There are so many sensors and system inbuilt into this box. So we have just developed it, and as I told, this is how the person face was recognized, and the details at the back end, it gets displayed in this way. So if you see here, the time and details, the timeout details, the basic details of the employee, everything was available for us, and it was easy by all means. Okay. So when it comes to the conclusion part, so this is something, if we are able to scale, this particular system, and with help of certain supercomputers or server storages in the cloud, if you are able to really extend it, then it will be very easy to literally deploy it in several places, and it's highly flexible in order to use it, or even to enhance. It's not a problem. If you have to add new features also, just we have to handle the model at the back end. We can easily add new features to it. It's not going to be a concern. And finally, the future is like this can be embedded in simple components also, like whatever accessories or things we are trying to use, even in that we can try to build it. So how we can take forward this is, once this particular model is able to do this facial recognition properly, and once those details are getting stored appropriately, then at least for those set of people, for example, as I mentioned now, those 30 people or something, the deep fake detection goes easy for us. So some changes being made, or some fake images being created, or some other things, or the hackers try to do something with the facial data, then these data, what we have in hand, will be obviously supporting us in order to do the recognition over there. Yes. So with this, I end my session. Thanks for your time.
Yeah. Thank you, Dr. Varalakshmi.
Thank you, sir. So I will stop the screen share.
Yeah, please.
Yes.
Dr. Giovanna?
Yes, here I am. Good
please.
afternoon.
Yeah. Good afternoon. Sorry for making you wait.
Yeah. Yeah, I'm going to. Okay. I would like to thank you, all my previous colleagues, because all their interesting presentations give me a good opportunity to have important insights, because this is a very large topic, taking into account the different aspects of the deepfake. Of course, my background is in business administration, so I would like to share with you what could be the implications for managers if whether deep fake happens in the real world of the companies. And of course, in Italy, there is a motto that the translation is, it is no longer enough to see to believe, because today if we see something, of course, we cannot believe, because probably there could be a fake under the news or any kind of the pictures of or the any kind of communication things. Of course, deep fakes, you underlined before, can be used to manipulate and threaten individuals and corporations. That's the why I would like to concentrate my presentation on the side of corporations, on the side of the companies. Of course, this figure here shows us the different kinds of manipulation that can happen in the real world of companies. Of course, on one side, there is the contents, and on the other also there is how to stop the rumors, and on the others, the law. So the aspect that is how to protect this kind of companies according to the situation, and how to stop the rumors at the beginning of the deep fake. So we have to see the rumor containment strategies, of course, the formulation and policies of regulation, because this topic I'm going to also to exploit the Italian context. Of course, this topic is becoming really new, even if we have the postal policy that is doing a really good stuff on trying to identify not only the pictures, but also who is on the back of these associations. And of course, another issue for the company is to clarify rumors, to block the rumors and influential users, and of course, to block the rumors and bridge and social communities. Of course, one case is the political propaganda, because of course, in the political propaganda, the technique is to polarize the discussion, and of course, with the polarization of a clear topic that can divide the followers into different stuff, and so they can avoid the vote, or to create a discussion, to create rumors, to create bad discussions. And of course, as my colleagues explained before, and thank you for all the stuff that save the image and to try to see if these images are good or not. I'm going to talk about the case of a bank of United Emirates, because also here in Italy, there are a lot of deep fake invoice. For example, I'm going to explain this case, and after I'm going to explain what is happening in Italy. This is a case of 2020 of the Emirates, where there was a bank manager who received a call, and whose voice is similar to a director of the company. And the director had a good news about the company to make an acquisition. And so he needed the bank authorization to transfer $35 million of amount. They also have in this case a lawyer in the bank that is in charge of kind of stuff, and they of course they received emails with protected code, and in the end unfortunately there was this kind of the deep voice technology, and so they lose this money. And of course they are doing even today they are doing they are trying to see what is the society behind that, and they identified 17 at least 17 individuals that of course try to attract not only for the deep voice, but also to don't protect the data of the bank. And that's the why today the banks and also the collateral banks, for example, in Italy, we also have the postal banks. And nowadays there are a lot of fraud in this kind of stuff. People call the owner of the bank account and says that, but the voice is similar to an employer, to someone that they have already known and they trust him or her. And that's the why there is the issue on one side of course, to protect the consumer, and on the other to protect the company itself, even if with the management of this kind of data, we need to see also how and to what extent the banks and the other companies are protecting the data of their customers. So this is a big issue because of course people, and in Italy we have, of course I live in the south of Italy, and there are a lot of people that all the money they had in that bank, they lose all. And of course there is a big social issue. So from the deep fake to the deep social issue, because of the artificial intelligence is doing more than we would like to have. And of course, there are the processes that are not so fast to identify. And of course, we need to protect our companies with big systems of privacy, and to also inform the customers of all the ethical points, not only when they sign the contract, but also try to explain and to do more training activities also for the customers, because we have to protect them. Of course, for the social issue and the pictures on the other cases, they are working, as my colleagues explained, on real-time collected databases, on real-time learning. So thank you very much for your attention, and I'm at your complete disposal for any kind of questions or to work after for a paper or a research. Thank you so much.
Thank you, Dr. Giovanna. Dr. Aditya, please take over.
Yeah. Thank you, sir. So it was very nice and wonderful from all the speakers. Sir, after this presentation, can we come to a conclusion, like who would like to take which part of this paper writing?
Okay.
So we shall have a little bit discussion on this because this is quite important. We cannot expect that everyone will be expert in all the domains. Okay. So let us, divide this work and work forward.
Okay.
So we can give chance to anyone, sir. Anyone who feel is good in that portion. Let us take, no problem. So we shall list out now only. So I'm just writing the things, sir. Who would like to
please share so that we can contribute right away.
Yeah, I'm just sharing the screen, sir. Can you able to see, sir, my screen?
One second. Yes.
Yeah. So can we start with anyone like who wish to take any part of this, or you can also kindly suggest if we miss anything in this. Yeah. Dr.
No.
Varalakshmi,
Yeah,
or
Dr. Varalakshmi, where would you like to contribute, Dr. Varalakshmi?
Sir, kindly give me some time.
Okay.
Please look at this document. I'll go through it and I will get back, sir.
Okay, okay.
So
Okay.
just I need to go through it, like which one I can contribute.
No, that is okay. Even with a guesstimate, what kind of a topics would interest you?
yeah.
So that we'll put
Just-
a name and we can add a few more names also, so that people can get added or eliminated or modified, whatever it is.
Okay, can we just have a look of that word document?
Can you share? I mean, show it in a big screen.
Yeah, I'm showing, sir. It's not visible.
It is half 2 pages. Make it into a single page. Make it bold.
Single page view and yes, sir. So now when it comes to the if you can kindly scroll down, sir. If we can come to the table creation in several places, what we have mentioned, like 20 to 30 papers. So is it like we are going to collect it from everyone or individually? If suppose I take it up, I have to speak about 30 papers over there, or
No. Yeah, everyone contributes. This is a team.
Okay. So roughly how many papers we might be
Somewhere
expecting?
about 5 pages per person will come.
5 pages.
Approximate. Yeah, approximate.
Ma'am, it's nothing like that. As much as you can.
As much as you can.
Yeah. See, suppose you are taking only for this portion. So if you can contribute around 10 to 20 papers, that would be great only. Right. So it's not nothing fixed, right? So the better you can do, it's better for us only. That's what.
That's true. Because in the whole plan, I see a lot of survey. Many things are going towards a survey. So I was thinking like, kindly scroll down, sir. Okay, discussion and comparison of various deepfake detection techniques.
Would you feel anywhere we can add some new things into this work, or anything new you would like to add? That also kindly suggest.
Okay, because earlier we had the case studies also as part of the paper. So I was trying to pull in my work over there.
Okay, nice.
Okay.
Dr. Aditya, can we also open up we'll include case studies and things?
Of course, actually, I written here an example of deepfake.
There you put it as a case study.
Also, case study can be
/ case study.
Okay.
Okay.
Yeah, that is the case, and for sure I will go with that thing.
Okay.
It's only 1 page, Krishna sir. Like, is it fine?
No. You can have as many pages as possible. He is taking a limit. Because on a pessimistic style he's taking.
We will have first initial draft, and after multiple round of verification review among ourselves only, we will come to a final conclusion.
Okay, then I will go this way, sir. I will try to collect a few real life examples of deepfake detection.
That is correct.
What is happening, like more oriented towards facial deepfake detection. And in that, I will try to pull in my work also and explain it. So I'm not consigning to 1 page as of now. I will share how much ever possible from my end, sir. All the details, I will share it in depth.
That's great. Okay.
That's good.
So you would be taking care about this example case things, right? Okay. Thank you, madam.
Yes.
Okay. Apart from that, any other part you would like, madam? Or let us first this one.
Sir, as of now, I will work on this. I will see if I'm able to finish this quite early, then I can for sure contribute for surveys also. Because when I do this itself, when I try to search for example itself, it is like a survey only. I'll be searching for papers. So those papers, I will try to add it as a survey also in that work. Wherever it fits in, we can add it into that survey.
100%, right.
My suggestion is, Dr. Aditya, you can have Vaishali for surveys also, because she is an expert in that.
Okay. Madam is comfortable, Vaishali madam?
I think she is left. I have texted her to join, even if she doesn't, not issue.
Survey means you need to deepfake generation techniques, different techniques. And,
yes.
Okay.
No, she has already presented today. Based on that, you can also look into it.
Yeah, sure. Okay, sir.
Now, Dr. Comfort.
Yes,
Dr.
I'm
Prakash?
here.
Yeah, ma'am, where could you contribute in this?
I've done some work already. I'll send it to you. Maybe look at it and know where it fits.
Okay. Any keywords you would suggest by now?
I was thinking we can, apart from the work one, we can look at maybe adding critical thinking or biological science apart from, because basically in detection now we're just looking at models, we're looking at the AI area of detection. So if we can diversify a little and see how the role of biological science in detection. So
Okay.
So detection, detection only, sir.
Yeah, detection.
yes, detection. We can look at a hybrid of both the AI and human input towards detection.
Okay,
That's
fine.
critical thinking.
Okay, great. So
the visual deep fake you have kept, Dr. Aditya. There you can put Dr. Comfort.
which one, sir?
A visual deep fake, lip sync, face synthesis, identity swap. You know, there I think she has the right.
Okay, great. Okay, sir.
Okay.
Hema, madam. Dr. Hema. She's there?
Yeah, I think she's there. Dr. Hema.
Yes, sir.
Yeah.
Please give your.
Hema, madam.
Yes, sir. Thank you, sir.
Which portion you would like to take, madam?
Sir, as I'm new to this topic and I'm just having that research simultaneously, sir. So,
Sorry?
sir, can you hear me?
No, madam, not properly.
Now, sir?
Yeah, it's fine. Please go ahead. Please go ahead.
Yes, sir. Sir, as I am new to this deep fake and I'm learning about this, so I am comfortable with introduction part and the techniques. So today I have gone through and have the concept of this neural networks, different neural networks part.
Okay, so you take care about this introduction. Before deepfake, we will be discussing a little about neural network, deep learning in the introduction part.
Okay, sir.
Right?
Okay,
so
sir.
you can take
Okay.
this. Okay. Okay.
Okay, sir.
Okay, madam. Right. Okay. Finally, Dr. Giovanna, I guess applications.
Yeah. Dr. Giovanna.
Yes.
Dr. Giovanna, can you take applications like the one which you presented to be included in the paper? Yeah.
Yes, of course.
So applications of deepfake.
Deepfake.
Okay, sir, we have you and me left.
Yes.
So which part you would like to take, sir, please?
You know what I'll do is whatever I have done, I'll share with you.
Okay, sir.
You fill it and see where it is suitably fixing.
Okay,
and
sir.
I'll contribute. I'll be flexible to contribute wherever things are required.
Great, sir. Then I will be focusing mainly on this technique parts, like this 20 to 30 techniques for both the detection and this one generation.
Very
and
good.
about evaluation metrics like loss function, other things. Okay. I'll prepare the table and discuss on everything, these things. And collaboratively, we can target this limitation, challenges, conclusion, future scopes.
Okay.
Right. That's where we can go ahead. And when we can set target.
You know what we will do first, Dr. Aditya, you share this to me. I'll put it in a Google Doc and I'll share it to everyone.
Okay, sir.
Then, as of now, they have all prepared something. Let them fit it.
Okay.
Wherever it will fit. And then we'll think about, consolidating it.
Okay.
Okay.
Okay, sir.
Okay. Thank you. And
Thank you, sir.
I
Thank
think
you
we have
very
done.
much. Yes,
Yeah.
sir.
I'm
Okay.
stopping
Thank
the
you.
recording.
Thank you,
Thank you all.
sir.
Bye.